Let me explain how each function is written or defined. That is the code inside each function. The left beat function starts with void left beat. You must use this syntax to declare a function. Also note that left beat is just a label or the name of the function. Just like some variables we used earlier, you can give any name you want, but it is recommended that you give a short and descriptive name. I gave the name left beat because that is what this function does, creates a single left beat. After naming the function, it starts with an open curly brace and the function ends with the closed curly brace. All the lines of code of the function must be between the open curly brace and the closed curly brace. The first for loop starts at 0 degrees and increases the value by 1 each time it goes through the loop, ending at 145 degrees. Also note that using this for loop, the left arm servo dot right starts the motor position at 0 and turns the motor by 1 degree each time the loop repeats. After each increase, it has a 1 millisecond of delay. So essentially, this for loop starts the left arm motor position at 0 and brings it to 145 degrees, just like what we saw in the previous programs. Similarly, the next for loop starts at the left arm motor at 145 degrees position and brings it all the way down to 0. The combination of these two loops makes the arm move up and down quickly, creating a single left beat. The function void right beat works in a similar way to generate the right beat. Note that this time I am using the servo motor connected to the right arm servo dot right. The first for loop starts the right motor position at 150 degrees, decreases by 1 degree all the way down to 50 degrees. The second for loop starts the motor at 50 degrees and increases by 1 degree and stops at 150 degrees. The ending positions are chosen based on how we want the robot to play the drum. This beat is a little softer than the left arm beat due to its different range of motion. The combination of these two for loops makes the right arm move up and down quickly, creating a single right beat. The function void head movement creates a head movement. It uses the motor connected to the head servo dot right. It first turns the yellow LED on by using the digital right LED to yellow high. The first for loop starts at 90 degrees, which is where the robot is looking straight ahead. It decreases the value by 1 each time it goes through the loop and ends at 0. Head servo dot right takes the servo motor from 90 degrees to 0 degrees. The second for loop starts at 0, increases the value by 1 each time it goes through the loop, and ends at 180. Once again, head servo dot right takes the servo motor from 0 degrees to 180 degrees. The third for loop starts at 180 degrees, decreases the value by 1 each time it goes through the loop, and ends at 90. Head servo dot right takes the servo motor from 180 degrees to 90 degrees. Note that 90 degrees corresponds to the robot looking straight ahead. Finally, it turns the yellow LED off using digital right LED to yellow low. Now I'll explain to you how we generate repeating left and right beats. The function repeat left right uses previously written functions left beat and right beat. It simply uses left beat 2 times and then right beat 2 times. So it creates 2 left beats and 2 right beats. First, it turns the red LED on using digital right LED1 red high. Then, it calls the left beat function using the line left beat to create the first left beat. Remember the left beat function we discussed earlier? It then turns the red LED off using digital right LED1 red low. Finally, it waits 10 milliseconds. It then uses the exact same 4 lines of code to create a second left beat. So now we have 2 drum beats, left, left. It then turns the green LED on using digital right LED3 green high. It calls the right beat function using the line right beat to create the first right beat. Remember the right beat function that we discussed earlier? It then turns the green LED off using digital right LED3 green low. Finally, it waits 10 milliseconds. It then uses the exact same 4 lines of code to create a second right beat. So now we have 2 more drum beats, right, right. So this function creates 2 left beats and 2 right beats, left, left, right, right. We chose to wait 10 milliseconds in between beats in this case. This is because we want really fast drum beats. You can choose to change the delays in between beats to create slower or faster drum beats, which we'll talk about in more advanced lessons. That's it. Easy, right? Do you see how useful the functions are? If I didn't write the function left beat or right beat, I would have to write all the lines of code again anytime I wanted to create the left beat or the right beat. But since I created left beat and right beat functions, I don't have to rewrite the code that is inside those functions. All I have to do is simply reuse those functions. As I said before, functions are very powerful. The use of functions makes the code easier to write, read, and manage. The function void sample1 is used to create one of the drum beat patterns. Left, 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 right, a total of 5 times, and each time it gets faster. The first left beat. It turns the red LED on using digital right LED1 red high. It then calls the left beat function to create a single left beat. It turns the red LED off using digital right LED1 red low. Then it waits 700 milliseconds, which is the same as 0.7 seconds. It uses the exact same 4 lines of code to create the second and the third left beats. So now we have left, left, left. Please note that between each beat it waits 0.7 seconds. It then creates the right beat. It turns the green LED on using digital right LED3 green high. It then calls the right beat function to create a single right beat. It turns the green LED off using digital right LED3 green low. Then it waits 200 milliseconds, which is the same as 0.2 seconds. So far we have left, 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 right, the first iteration. You may wonder why we're turning the red and green LEDs on and off. This is because we want the red LED to correspond to the left beat, and the green LED to correspond to the right beat. So we turn them on before the beat and turn them off after the beat. The next few lines of code do exactly the same thing. except it decreases the delay between the left beat to 500 milliseconds, or zero point 0.5 seconds. So the pattern left, left, left is a little faster, which is the second iteration. Now we have the second iteration of left, 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 and right. The next few lines of code do exactly the same thing, except it decreases the delay between each left beat to 300 milliseconds, or zero point 0.3 seconds. So the pattern left, left, left is even faster, which is the third iteration. Now we have the third iteration of left, 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 and right. The next few lines of code also creates the same left, 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 right, but this time it uses only 100 milliseconds, or 0.1 second between each left beat. So the pattern left, left, left is even faster, which is the fourth iteration. And finally, for the fifth iteration, it uses only 10 milliseconds between each left beat, so it is even faster, and then it stops. So the function sample1 creates the left, 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 right drum beat pattern 5 times, and each time it gets faster. Left, 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 right, left, 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 right, left, 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 right, left, 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 right, left, 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 right. The function void sample2 is used to create a little different drum beat pattern. This time, left, left, right, right, a total of 4 times, and each time it gets faster. The first left beat. It turns the red LED on using digital right LED1 red high. It then calls the left beat function to create a single left beat. It turns the red LED off using digital right LED1 red low. Then it waits 700 milliseconds, which is the same as 0.7 seconds. It uses the exact same 4 lines of code to create the second left beat. So now we have left, left. Please note that between each beat, it waits 0.7 seconds. It then creates the right beat. It turns the green LED on using digital right LED3 green high. It then calls the right beat function to create a single right beat. It turns the green LED off using digital right LED3 green low. Then it waits 200 milliseconds, which is the same as 0.2 seconds. It uses the exact same 4 lines of code to create the second right beat. Please note that between each beat it waits 0.2 seconds. So far we have left, left, right, right, the first iteration. The next few lines of code do exactly the same thing, except it decreases the delay between each left beat to 500 milliseconds, or 0.5 seconds. So the pattern left, left is a little faster. So we have left, left, right, right, which is the second iteration. The next few lines of code do exactly the same thing, except it decreases the delay between each left beat to 300 milliseconds, or 0.3 seconds. So the pattern left, left is even faster. So now we have left, left, right, right, which is the third iteration. And finally, the fourth iteration. It only uses 100 milliseconds, or 0.1 second, between each left beat and each right beat. So the pattern left, left, right, right is even faster, and then it stops. So the function sample2 creates the left, left, right, right drum beat pattern 4 times, and each time it gets faster. Left, left, right, right, left, left, right, right, left, left, right, right, left, left, right, right. So now I've explained to you how each function works, but the functions by themselves don't really do anything until they're called. Only the code written inside the main section, the void loop, is what gets executed. Meaning, this is the code that makes the robot perform certain actions, like making it play the drum beats. Let's see this in the code. It first calls the function headMovement, which creates the head movement and waits 500 milliseconds. Then it uses the function sample1 to create the first drum beat pattern. Remember that sample1 function creates the left, 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 right drum beat pattern 5 times, and each time it gets faster. That is left, 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 right, left, 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 right, left, 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 right, left, 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 right, left, 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 right. It then waits 5 seconds since I used the delay 5,000. It shakes its head again by calling the head movement function and waits 500 milliseconds. Next, it calls the function sample2 to create the second drum beat pattern. Remember the function sample2 creates the left, left, right, right drum beat pattern 4 times, and each time it gets faster. That is left, left, right, right, left, left, right, right, left, left, right, right, left, left, right, right. After a delay of 10 milliseconds, it then uses a for loop to call repeat left right function a total of 15 times, since the counter j starts at 15 and it goes all the way down to 1. It waits 1 second and repeats the entire process again. Pretty cool, right? Now that I have explained to you how the code works and what it does, let's see the robot in action. It shakes its head, then it'll play the first drum beat pattern, left, 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 right, 5 times, and each time it gets faster. It waits 5 seconds, and it'll shake its head again. Then it'll play the second drum beat pattern, left, left, right, right, 4 times, and each time it gets faster. It'll then continue the left, left, right, right 15 more times. The code I've written isn't the only way to write the code, and not necessarily the most efficient. I intentionally wrote the code in a way that makes it easiest for you to understand. There are many more ways to achieve the same outcome, but with differently written code that may even be more efficient. I will teach you that in my more advanced classes.